Hey students, in this notes, we're going to learn about the linear factors of polynomials, and what that means is that we're going to look at a polynomial function in factor form. So for example, these right here, you notice that these are all binomials in parentheses. These are all factors to the polynomial. If you graph this in the calculator, the graph will come out like this, and pretty much what you're learning in this lesson is how to not use your calculator to be able to predict how it's going to look. So things you're going to have to look for is, for example, the leading coefficient, which is at the very front, and then the multiplicities, which happens to be the exponents on each binomial, and then the roots, which, if you recall, anytime you have a binomial like x minus 3, and you equal that to 0 and solve for x, that results in giving you what the x-intercept is. So this binomial tells you that the graph is touching when x equals 3. So it's technically this number right here after the minus sign. So all the factors follow that template of x minus a root or 0 or x-intercept, however you want to see that. So these first two examples is just kind of telling you how to sketch from what you see. So you're going to be looking for what the exponent is for each binomial, because that's going to tell you what's going to happen, whether it's going to bounce off. If it's an even multiplicity, like an even number for the exponent, that's going to mean it's just going to like either loop like this, is going to bounce off, or coming up and then bounce down. So picture a line and picture yourself coming down and then bouncing up, or going up and then bouncing down. So that's what bounce off means. The next part to consider is if it's an odd multiplicity or an odd exponent, you're going to consider that it crosses there. It's going to cross at that 0. It's actually going to picture a line, and then wherever that 0 is at, the x-intercept, is actually going to cross it, whether it looks like that or like that, just based on your direction of the sketch. And then, of course, the higher the multiplicity, the flatter the curve. That means that if you have, for example, a quadratic is just like this. If you have like to the 4th power, then it will be like a flatter curve. So that's what it means by flatter. It just kind of squashes it down. All right, so for example here, this polynomial is graphed. It has 3 binomials, which means there's going to be 3 zeros. Again, you're looking for the template of x minus a number. So this has x plus 3. That means that your 0 is negative 3 right here. X minus 4. So that means 4 is another 0, or x-intercept or root. And then x minus 1. So that means 1 is a root. So if you look at the graph, that number 1 is right there. That number 4 is right there, and that negative 3 is right there. So this graph, if you type it in your calculator, it would show that it's touching at these zeros, these x-intercepts, because that's what the factors show. Now, as far as what degree is this polynomial, well, you look at the exponents that each one has. Right now, there's no exponent, so that means they each have a 1. So that means that if you add all of these multiplicities, it'll be a 3. So you add the multiplicities in order to consider how much is the degree. And then as far as the leading coefficient, you're going to look for the very front. What's at the very front? There's nothing, so it's all a positive 1. So when it's a positive 1, it's going to kind of follow the template of going up. If it's a negative, it's going to follow down. So if you look right here, the degree is 3, so that's an odd, which means that they're going to open in different directions. And then you just have to consider which one of these is the positive direction. So this is the positive direction because the line will be going up. So this is why it opens like this, different directions, and then it follows that template of the line. All right, so let's try one more time. we're going to look at the leading coefficient, which is -1/2. Sorry, leading coefficient was 1 over here. So leading coefficient is -1/2 right here, which means we're looking at a negative. The degree, we have an exponent of 1, exponent of 2, exponent of 1. So if we add all of these, we have 1 plus 2, that's 3, and then plus another 1, that's 4. So the degree is 4. So because the degree is even, we're looking at the graph opening same direction, either up, up, or down, down. And then because the leading coefficient is negative, we're looking at it opening down, down. So this is how all this could be found just by looking at the polynomial, not necessarily graphing it in your calculator. And then also we notice that the degree, the exponent right here is odd. So that means it's going to cross. This is an even, so that means it's going to bounce. And then this one is an odd, so it's going to cross. So I didn't specify that on the previous one, so I'll just show you again. When it's odd, it's going to cross. All of these are odd, so they're going to cross. So notice that it's going to open this way, down, up. So it's going to go down this way, cross, and then it's going to turn, and then it's going to come this way and touch right here, and it's going to cross. And then it's going to touch right there, and it's going to cross. So then on this one has the degree of 1. So it's going to cross at the 0 of 1. So 0 of 1 is right here. And then it's going to cross. This one needs to follow the template of x minus a number. So it's going to be -1. Your 0 is -1. So that means this 0, it's going to be bouncing. So notice how it touches and goes back up. So it bounces. And then on this one, it follows the template of x minus a number. So x minus -3. So it's going to touch at -3 and it's going to cross at -3. So it takes some practice for you to kind of predict how the sketch is going to look. And we'll do that. So just things you need to remember is if you have a positive leading coefficient, you need to consider that you have up, up on the ends. So that's why it has even degree. Up, up, and then if it's odd, it's going to follow a positive line. So down on this end, up on this end. If it's a negative leading coefficient, you're going to end up with down, down. So that's why the arrows are going down on both sides. Or a negative line if it's an odd degree. So it's going to be up from the left and then down from the right. So use this template to help you know how the end behaviors are going to be. All right, so let's take a look at the back. I'm going to make another video of the examples if you guys want to watch those. But hopefully you understand it a little bit.